Hello, my name is Jimmy Costello from the NX Product Marketing team. Today, we're going to be looking into the basics of how we can create lattice structures within NX. Lattice structures are an important part of additive manufacturing. Essentially, they are repeated patterns that fill a volume or conform to a surface. They are particularly advantageous in applications where weight reduction, energy absorption, and tailored mechanical or thermal performance are crucial. The ability to design lattice structures with specific functionalities, combined with advancements in additive manufacturing, have made them an attractive choice for engineers and designers seeking innovative solutions. To get started, we can begin by opening the Design for Additive Manufacturing tab. Inside of here, there is an entire group dedicated to lattice design. Next, we can select the first command within this group, labeled Lattice. This command will provide a number of options so we can effectively produce a lattice design that fits our needs. Today, we're going to walk through each of the different options to get a better understanding of what context each choice should be used under. The first and most commonly used lattice type will be unit fill. This fills a boundary volume with a lattice by patterning a unit cell in all three directions and then trimming it back to the body. To do this, we simply need to select our boundary body, and from there, we can choose our unit cell. When choosing our unit cell, there are a number of options to pick from. Each choice provides a different lattice design. It's important to investigate which lattice cell is best fit for your needs. Moving along the command window, if you want a more realistic lattice design, randomizing graph nodes will produce a less uniform end product. And lastly, before you finish, you can control the rod diameter and if your design has balls and blends. For this design, we're going to leave the rod diameter as is and add balls with absolute size. Once we're finished, we can go ahead and hide our initial block to view our new lattice structure. The block simply served as the boundary for our lattice design. Continuing on, let's look at the other four types of lattice structures we can produce from the lattice command window. If we hide the lattice structure we just created, we can again use this same block for our second scenario. This time we're going to use the Unit Surface Conformal option. This allows us to select the face or faces that our lattice will adhere to. Instead of a volume fill, this will produce a lattice that extends along the surface of our shape or body. Again, we have the same basic settings as before, allowing us to customize our unit cell and set up a lattice structure that fits our design needs. The next option we're going to explore in the lattice command is Unit Volume Conformal. This option functions similarly to the unit fill choice, but instead of selecting a body, you select a base face. Again, the volume will be filled with a lattice design, but this time the body will be divided into voxels, and a unit cell will fill each voxel. Once again, when we finish, we can hide our boundary body for our lattice design. The fourth lattice option we're going to explore is triangular. This choice again provides a different style lattice structure. This time, it can be used on surfaces or volumes using the graph output dropdown. This option will create tetrahedron structures, and it will use facet edges as rods. For options like this sphere that don't have edges, it can still produce a lattice structure on the surface, but we will not be able to output a lattice volume. And finally, the last option in the lattice command window is Voronoi. Again, we are prompted to select a face and then our lattice design will populate in. After that, we can optimize our pore size and distribution. Using a Gaussian distribution will produce a normal bell curve style output for our pore sizes. Before we wrap up today, there's one last thing I want to discuss regarding our lattice designs. If at any time we want to edit our existing lattice structures to change rod diameter, balls, or blends, we don't need to reopen our lattice features from the Part Navigator. Instead, if we navigate to the lattice group, we can select rod thickness. This command allows us to select existing lattice structures and alter the rods, balls, and blends. Once we're finished, a new feature for this change will show in the Part Navigator, making it easier to make changes to the body of your lattices down the line. In conclusion, in this video, we've explored the basics of using lattice structures in NX. We began by creating a unit fill lattice design on the block. Here we explored the unit cell, randomizing graph nodes, and body creation. After that, we dove into what the other options were for creating lattice structures within the lattice command window. And finally, we wrapped things up by investigating the rod thickness command to make changes to our existing lattice designs. I would like to thank you for your time and attention.